So let's talk about quadratic equations. A quadratic equation is a second-degree polynomial. Well, actually, since it's an equation, it's a second-degree polynomial that's inside of an equation. So ax squared plus bx plus c equals 0, so that equals 0 makes it an equation. So a is a number. In this case, since we want this to be a second-degree polynomial, we want there to be an x squared term. So what second degree means is that the highest exponent is a 2. So here I see the exponent 2, and here I see the exponent 1, which is implied, and here actually is the exponent 0. So this is an implied 1, and this is actually an implied 0. So you could write times x to the power 0, because you know that anything raised to the power 0 is 1. So x raised to the power 0 is 1, and c times 1 is c. So there's actually the power 0, the power 1, and the power 2, the highest power being 2, which makes this a second order polynomial, which makes it a quadratic curve, and since it's inside of an equation because of this equal sign, it's a quadratic equation. So what does a quadratic equation look like if you were to graph it? We can't graph an equation, but if we graph the left-hand side, it would look like a parabola. So a parabola has a shape kind of like this. You'll see this type of thing is if a is a positive number. By the way, we've agreed here that a cannot be 0. If a were 0, then that whole first term is gone, and now you have bx plus c equals 0, and that's a line. So now this is a linear equation, and we've already talked about those in a previous video. So if a is positive, you'll see it, the parabola cuts upwards, and if a is negative, you'll see something that looks like this. The parabola that's cut downwards. So how do you solve a quadratic equation? Let's go over a few algebraic concepts that we're going to need to know over the course of this class. So if I were to write, we all know that if I were to write, let's say 2 squared, that's 2 times 2, and that's 4. So we're gonna have to be able to square things and take the square root of things very carefully, right? So if I were to take a negative 2 and square it, that means I want negative 2 to be multiplied by negative 2, and that's also equal to 4. So the negative signs in that case cancel each other out. So if I were to write, or if I were to ask you the question, what is the square root of 4? Well, you would tell me the square root of 4 is 2, because 2 times 2 is 4. But I could tell you, negative 2 is also a square root, because negative 2 times negative 2 is also 4. So the answer to this question is, so the square root of 4 is 2, because square roots are positive. So the square root of 4 is 2 because two times 2 equals 4. So that's fine. What if I asked you to find the square root of a number that I did not give you? So for example, solve for x. So x squared is equal to 4. And so you would look at that x squared and you would think, I would like to get rid of that square because I'm trying to get x by itself, because the question says solve for x. So what I want to do to get rid of that square is take the square root. So I'm going to do the same thing on both sides. So I'm going to take the square root of x squared. And on the right, I'm going to take the square root of 4. Now on the left, we're going to use this definition. We're going to use this definition a lot today. This definition is the square root of x squared is equal to the absolute value of x. So what that means is the absolute value means whatever x is, you make it positive. Whatever's on the inside, you make it positive. So using that definition, in our previous equation, we have the square root of x squared is equal to the square root of 4. So earlier over here, we found that we know that the square root of 4 is 2. And on the, so I'll put 2 on the right hand side. Now on the left, we're going to use this definition and replace the square root of x squared with the absolute value of x. So now I've got the absolute value of x equals 2. And so I think to myself, I'm trying to get x by itself. What does this absolute value of x equals 2 mean? What it means is whatever x is, once you make it positive, you get 2. So I think, which numbers can I make positive to get 2? So the answers are 2, it's already positive, and negative 2. If you make it positive, you get 2. So the answer here is x equals plus or minus 2. So let's solve a couple more of these, and then we'll get back to the quadratic equation. Just need a little practice working with these square roots. Let's say 3x squared minus 1 equals 0. So I want to get the x by itself. So let's just do regular old algebra first. I want to add a 1 to both sides. So 3x squared is equal to 1. You got to use your order of operations, PEMDAS, parentheses, exponents, multiply, divide, add, subtract. You want to use that backwards when you're solving for x. So I do the subtraction first, now I'm going to do multiplication. Well, see, I see the 3 is being multiplied, so I need to divide it on both sides. And now I'm left in this situation that I was in before. I know that the square root, well, let me take the square root of both sides. So the square root of the left is equal to the square root of the right. And for now, we'll talk about what happens when the right-hand side is negative, but for now it's positive, and I'm just going to keep going. So what is the square root of x squared? The answer is absolute value of x. So I'm going to write absolute value of x is equal to, so on the right, in the previous problem, I knew the square root of 4 is 2. And this problem, I don't really know what the square root of 1/3 is. I could use a calculator, but it's easier to just leave it alone. So I'm just going to leave it alone. It's a number. Whatever it is, it's fine the way it is. I'm just going to leave it alone. Now, this equation is telling me that whatever x is, I'm at the final step here, trying to figure out what x is. This equation is telling me that whatever x is, once you make it positive, you get the square root of 1 over 3. So x is either positive or negative square root of 1 over 3. And that's it. And you might want to check your work. Let's check our work. So to check your work, you take your solution, you plug it back into the original equation. So let me draw a vertical line here. Whoa. So the original equation is here. So 3 and x is plus or minus the square root of 1 over 3. And then original equation says square. Original equation says minus 1 is equal to 0. And I like to put a little equal sign, or a little question mark here, because I don't know that those are equal. That's in fact what I'm trying to find out. That's what I'm checking. So I don't want to just write an equal sign like it's automatically gonna be equal. So here, 3, leave that alone. Let's deal with these exponents. So in the case that I have a positive number there, if it gets squared, it's still positive. In the case that I have a negative number on the inside, you can think of it as like -1 times that number. And when you square -1, you get 1. So either way, you're just going to have a positive number here. So now we're looking at the square of a square root. And so here's the definition that we need to use. And this one is easier than the other one. The definition. So if you have a square root of a number and you square it, you just get that number. So in this case, I have the square of the square root of 1/3, and so I would just get 1/3. And then there's a -1, and I'm checking to see whether that is equal to 0. So 3 times 1/3 is 1. Now I'm starting to get pretty confident. I got 0 is equal to 0, and that is true. So I'm happy with my answer there. X is equal to plus or minus 1/3. Quadratic equations, the ones we've been solving so far, have the power of 2 there, but they don't have the power of 1. And when you have the power of 1, things get a little more tricky. So let's just take some observations about how these things are constructed. So what if I have, to get a power of 2, let's say I was able to factor this equation into 2 linear pieces. Like if I have x plus a, and if I multiply that by x plus b. Well, you might remember FOIL. So the way I want to multiply this is with the method called FOIL. And I even like something more general than FOIL. I don't actually like FOIL, but let's do FOIL first. And then I'll tell you the way I like. So you multiply the first one, and then the outer one, and then the inner one, and then the last one. So what does that mean? This is going to be equal to 4 things summed together. The first thing is the 2 first terms multiplied together. That's first. And then the outer, so the outer ones are the x and the b. And then the inner ones are the a and the x. And then the last ones are the a and the b. So first, outer, inner, last. So let's write that down. We'll just go in that order. Since you're adding all the terms together, the order really doesn't matter, but if you want to use FOIL, then let's do that. So first, x times x is x squared. Outer, x times b is bx. The inner terms are a times x. And the last terms are a and b, so a times b. So then there's one simplification you can make. The two terms in the middle have the same power of x. It's a times x plus b times x. So I could write a plus b times x. So this is a quadratic polynomial. It's got x to the power 2, it's got an x to the power 1 here, and it's got a constant term, which is just a number, which is x to the power 0. And I can use this to, well, I can use this method going backwards to factor and solve quadratic equations. So let's try that. Just going off this observation about how these things are multiplied together, let's try one. So I want to solve, let's say x squared plus 6x plus 5 equals 0. So what I'm going to do first is called factoring it. And just like I would factor, so I'm going to factor this. So factoring, if you remember, factoring a number means writing its multiplying, what do you think? Well, they're called factors. So 15 is equal to 3 times 5. 3 and 5 are the factors that you multiply together to get you the product called 15. So we're going to do the exact same thing. In fact, this is what I did over here. The quadratic polynomial x squared plus a plus b times x and then plus ab that you see here. If you factor that, you get x plus a times x plus b. So I'm going to do that exact same thing with this. So what I need to do, I'm just going to have to play a little matching game here. I see a 6 that's multiplying the x, and up here in my little formula I know that that needs to be a plus b. So basically I'm trying to find a and b so that I can write this. So I can write this as x plus a is going to go here times x plus b. Well, I don't want to write that. And it's still equal to 0. So I'm just looking for a and b, really. And I know that a, whatever is multiplying my x here, which is 6, that's got to be a plus b. I also know that this constant term at the end, that's got to be a times b. So I'm just matching these two things together. So that tells me that a plus b is equal to 6 and a times b is equal to 5. So at this point you just need to kind of think about it and try to think of two numbers, a and b, such that when you add them together you get 6 and when you multiply them together you get 5. And just keep in mind that you're probably getting a homework problem out of a textbook and they're not going to make it some horrible decimal number that you would never be able to think of. So let's just list some possibilities. So my recommendation is that you write down pairs of numbers a and b that multiply together to give you 5, like integers. So this is the other way, and then so once we write down a bunch of a's and b's that multiply together to give you 5, we're going to look in that list and see which ones also add together to give you 6. Maybe you're thinking of those two numbers right now. Now if I were to go the other way and try to write down a bunch of numbers that add together to give me 6, I would have a huge list and it would take a lot more time. So just keeping in the back of my mind that this problem's coming out of a textbook probably, and the answer is not going to be too difficult, I'm going to write down all the numbers that I can multiply together to give me 5. So let's do A is 1 and B is 5. Or I could say A is 5 and B is 1. Now look at this for a second. I just guessed the same two numbers but in a different order. But if you look at the conditions here, A plus B, it doesn't matter if I do A plus B or B plus A, it's the same. And it doesn't matter if I write A times B or B times A, that's also the same. So I don't need to duplicate my guess here and guess, or write down as a possibility 1, 5, and then also 5, 1. That's redundant. In this case, that's redundant. So I'm not going to include that guess. But there is another possibility. I could have A equals -1 and B equals -5. So these are the possibilities for A times B equals 5. And now, of course, we're talking about, I'm just writing down integers here, hoping that one of these is the right answer and expecting that it probably will be. But I could write down infinitely many fractions that multiply together to give me 5, or decimals, or real numbers, or what have you. But I'm just thinking probably the answer is going to be a couple of integers. And in fact, if you look at this pair, you get A times B equals 5 and A plus B equals 6. So that works. Great. So it's A is 5 and B is, well, A is 1, B is 5, or vice versa. Doesn't matter. So that means I found A and B, and if I look back up at my formula here, I originally started with x plus A times x plus B. So that means now I can finally write, and now I'm finally getting back to this after guessing A and B. And that really was just guesswork. Educated guesswork. So now I can write x plus, so we said A is 1, so x plus 1 times x plus 5 is equal to 0. And now you might think, hey, Todd, Dr. Smith, you're trying to solve for x, and now instead of x squared and x, now you've got 2 x's, and are you any closer to actually writing down x equals this and x equals that? And I would say, yes, I am, because I know, we know that if I have one number, I'll use capital A, and I multiply it by another number, capital B, and that's equal to 0. This is one of those nice properties of 0, that the only way to multiply numbers together and get 0 is if one of those numbers, at least one of those numbers, is 0. So I know that if I have two numbers and I multiply them together to get 0, then either A equals 0 or B equals 0. Or both, because 0 times 0 is 0. And these are in fact numbers, X plus 1 is a number. It's just that I don't know what x is, so I can't write down what the number is, but whatever x is, you add 1 to it, and that's a number. And x plus 5 is a number. So I basically have a number times a number equals 0. So I know that either x plus 1 equals 0 or x plus 5 equals 0. And this is great because now I've got two linear equations. This happens all the time in mathematics. You learn a new subject, you do the new stuff, and then the problem reduces down to whatever you learned last week. And so last week or yesterday we learned about linear equations. Now we're doing quadratic equations. So you do the new quadratic stuff that you learned, and then the problem reduces down to linear equations. So now we know how to solve both of these. So this equation implies that x equals -1, and this equation implies that x equals -5. So this equals with the greater than sign means implies. It's a logical implication symbol. So this equation on the left implies this equation on the right. And so on the right, we've got two answers for x. X could be -1 or x could be -5. And so I think we should check our work. So where's my original equation? X squared plus 6x plus 5 equals 0. So let's check x equals -1. So you just have to check both x values individually. So I'm going to plug in -1. So that's -1 squared. And then I'm going to plug in -1 into this x. I've seen people in my class make the mistake that they want to plug one x into one x and the other x value into the other x, but you're just doing one at a time. So in this pass through, I'm doing x equals -1. So all the x's are -1. So -1 squared is 1. 6 times -1 is -6. And then plus 5 equals 0. So 1 minus 6 is -5 plus 5 equals 0. And that works out. So also we have x equals -5. So -5 squared plus 6 times -5 plus 5 equals 0. Maybe you want to, just to remind yourself what you're doing here, the thing I'm checking is this equality. So I don't actually proclaim to know that this is true, but when I get to the bottom, -5 plus 5 is equal to 0, so that is true. So this is what I'm checking. So -5 times -5 is 25. 6 times -5 is -30. And plus 5 equals 0, question mark? Does it? 25 minus 30 is -5, plus 5 is 0. And that is true. So my answers are correct. X equals -1 and x equals -5. Both of those x values solve the quadratic equation x squared plus 6x plus 5 equals 0. Now you might notice that there's two solutions and we're working with a second degree polynomial, and you might think, hey, is it always the case that if you have a second degree polynomial you have two solutions? And the answer is yes. Now it's possible that those two solutions are the same number, and so you could argue, oh hey, that's only one solution, but it's actually the same solution repeated twice. They say it has a multiplicity of 2, but either way you're going to get two solutions, maybe repeated. So you could generalize and say, well, if we have a cubic equation that has x cubed in it, the highest power is cube, which is a 3, then we're going to get 3 solutions, and that's true. And in general, if your highest power is x to the n, you're going to have n solutions. So let's go over imaginary numbers. So far, in the examples above, underneath the square root, I had positive numbers. But that's not always the case. Sometimes I have a negative number under the square root. And so in that instance, we're going to use this definition. This happens a lot in mathematics too. There's some strange thing that's going on, and we say this, maybe it makes sense, maybe it doesn't make sense, but we want to move on with the theory. So let's just take this one thing for granted and then see how much math we can get, like squeeze out of it. So I'm going to make a definition here. If I ever have to write the square root of -1, well, so previously, if I wrote the square root of 4, you would say that's 2 because 2 times 2 is 4. But if I ask you what's the square root of -1, you're going to say, I don't know, there's no two numbers you can multiply together that'll get you -1. And that's true, there's no two real numbers. So that's why we have imaginary numbers, just for this one reason. And so I'm going to write the square root of -1 is I. That's a lowercase I. And it stands for imaginary, of course. That's called the imaginary unit. And so we're just going to take this to be a definition, and that's the only imaginary thing we have to just accept. And then besides that, we're going to get back to strict logic and mathematics. So I'm going to take this definition, and I'm going to say, well, now that I have this definition and I'm accepting it as fact, I can square both sides. I can do, I can add 1 to both sides. I can just do regular math. So I'm just going to square both sides. So let's just see how much stuff we can get out of this. So I is a symbol. We've just created a symbol to suit our purposes. So I don't really know what to do with the right. I can't do anything with the right side. It's just I squared. But on the left-hand side, I have the square of a square root. And in that case, we already know what that is. The square of a square root is, let's see, there it is, the square of a square root. It's just whatever's on the inside of that radical. It's called the radicand, the stuff on the inside of the radical. So in this case, the radicand is -1. So I squared is equal to -1. So that's going to be useful. So you do have to accept this definition of this new symbol I, which is just taking the place of the square root of -1. But once you accept that one thing, you can continue to do regular old algebra on it. So we can write I squared. It's a little backwards. I squared is equal to -1. So let's use that and solve an equation. X squared equals -5. So you would look at that just right off the bat and say, well, I need to know a number that I can multiply by itself that'll give me -5. And then it might not come to you immediately. It wouldn't come to me either. But that's okay. We can just do math. And so we don't have to think about it. Just do math. So I need to get that x by itself. There's a square. So to get rid of that square, I take a square root. And of course, you have to do the exact same thing on both sides of the equation. So on the left, I have the square root of x squared. And that is a definition that we already have. Let's look for that. There it is. The square root of x squared is the absolute value of x. So on the left-hand side, I'm going to write absolute value of x. And on the right-hand side, I'm just going to leave this alone for the time being. Now let's do a little theory in here, a little theory. If I have the square root of one number times another number, that's equal to the square root of the first number times the square root of the second number. And I'm just going to use that here now. So I'm going to leave the left-hand side alone for now. So I'm going to leave the left-hand side alone for now. On the right-hand side, I'm going to recognize this negative 5 is just negative 1 times 5. So I'm going to write this as the square root of negative 1 times the square root of 5. And now I know what the square root of negative 1 is because I'm just going to use the definition. The square root of negative 1 is I. It's the imaginary unit. And it's really just a symbol, and all the symbol means is the square root of negative 1. So I'm really just writing the symbol for this quantity. And then times the square root of 5. So I've got absolute value of x. Now I'm thinking I need to get x by itself, but it's not by itself because of those absolute value bars. So the absolute value bars are telling me whatever x is, when you make it positive, you need to get the thing on the right-hand side. And so basically that means you could already have the thing on the right-hand side, or you could have the negative of that. So you could have plus or minus I times the square root of negative 5. And it looks nicer. You can multiply things in any order, you know. So it just looks nicer, kind of, if you write the square root of 5 times I. That's usually how you'll see that written. So that's x. You have two solutions. Positive square root of 5 times I and negative square root of 5 times I. And so we should check. We should check our work. You always want to check your work. So my original equation was x squared equals negative 5. So I've got two solutions. So I want to check both of them. So the first one I'll check is x equals positive square root of 5 times I. So the equation says x squared. So I'm going to write x. X is the square root of 5 times I. So that squared should equal negative 5. I'm going to put a little question mark here because I don't know that those are equal. That's what I'm checking. So here's a little theory, and this is actually the exact same theory that I wrote over here, but if I have a number a times b and they're being multiplied together and raised to some power like 2, then that's the same thing as raising a to that power and raising b to that power. So I'm going to use that to write, so I see two numbers here, the square root of 5 and I. So the square root of 5 is being squared and I is being squared. So I've got the square root of 5 squared times I squared is equal to -5? Question mark. So the square of a square root, that's a definition that we already had. You just write the inside, the radicand. And I squared, that's the definition we have right up here. I squared is -1. So this 5 is being multiplied by -1. And at that point it's pretty clear. 5 times -1 is -5. So that works out. And the other solution will work out just the same way. You would have a negative sign here. The negative would get squared. -1 times -1 is 1, so it would kind of just go away at this point, and you'd end up with the exact same equation at the end. So let's solve a quadratic equation that's a little more complicated than what we've been solving. I'll make it up. Let's say 5x squared plus 2 is equal to 6. So a lot more numbers here, but it's okay, you know, it's fine. I'm just going to do the exact same thing. Actually, I want to use the I, so I'm going to make this number, let's say -6. Okay, so I want to get x by itself. So what do I need to do first? I need to get rid of that 2. So I'm going to subtract 2 from both sides, get -8. Now I need to get rid of that 5. So when I divide by 5, I get -8 over 5. Now I need to get rid of that square. So I'm going to go slowly here because a lot of my college algebra students in the past, this is the part where they trip up. Because before it's just basic algebra. Now we're doing the new stuff with the square roots and the absolute value signs. So let's go slowly. What I want to do is get rid of that square. And the way to do that is to take a square root on both sides. And I'm going to write the whole thing. One thing I recommend always is, even though it takes a long time, write out every step that you need to see. Don't try to skip steps that you need to see. So over here I didn't write -2 on both sides, but I don't need to see that, and I don't think you do either. But here, getting rid of the square with the square root and the absolute value stuff, I think we all need to see that. So I'm going to write all of that. So on the left I have the square root of x squared, and that's it. We have a definition for that. That's absolute value of x. And I'm going to go ahead and do some simplification on the right too. I see that negative sign. I know that I'm going to have to use an I at some point. So I recognize this -8/5 as -1 times 8/5. So I'm just going to write that. -1 times 8/5. So let's leave the left-hand side alone for a bit. On the right, I'm gonna simplify this as square root of -1 times the square root of 8/5. Now the square root of -1, we have a symbol for that. The symbol for that is I. So I'm gonna write I. It's the imaginary unit, and that's multiplying the square root of 8/5. And I would never put that in a calculator and try to write down a decimal. It's just pointless. This is the absolute value of x. So that's telling me that whatever x is, once you make it positive, you get the stuff on the right. And so therefore, x has to be either positive or negative, all the stuff on the right. So there's my x. If maybe this time we could check it kind of mentally. I'm looking at my original equation here. So I have x, and the first thing that happens to x, you can see, is that x gets squared. So if we look down here and see what happens when I square x. So if I have a positive 1 multiplying, is 1 times 1 is 1. If I have this negative 1 multiplying, negative 1 times negative 1 is 1. So either way, I'm just going to have a 1 here. When I square the I, I'm going to get a negative 1. And when I square this number, I'm going to get 8/5, because the square will just cancel the square root. So in the first step, when I square the x, I'm just going to end up with 8/5, or the negative 1 from the I, and then times 8/5, so negative 8/5. So now, if we're looking over here, I've got negative 8/5 as a result of this part. If I multiply that by 5, negative 8/5 times 5 is negative 8, and negative 8 plus 2 is negative 6. So that works out. So let's talk about the quadratic equation. So this is a way of solving all quadratic equations. I should have said, let's talk about the quadratic formula. The quadratic formula is a way to solve all quadratic equations. So the most general way you could write a quadratic equation is some number is multiplying an x squared, and some number is multiplying an x, and some number is a constant, and that's equal to 0. And I can write down the solution. Well, I'm writing down the quadratic formula. The quadratic formula is, and this is just the solution of x right off the bat, so you can use this whenever you want. You might have to do a little algebra to get whatever equation you're given into this kind of format, but after you do that, you can just write the solution down, which is very nice. So the solution is, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I like that, 2a. I emphasize the all over. I've seen people in my classes draw over 2a. That's wrong. I've seen them do just the square root, and that's wrong. The whole thing over 2a. So the whole thing is the numerator, and then divided by 2a. And there you go. This formula can be derived, which is fun, but not necessary, because you can just memorize this formula, and then whenever you need to solve a quadratic equation, you can just write down the solution. It's great. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's try. For example, solve Okay, so 3x squared minus 2x plus 1 equals 0. So I just need to identify the constituent parts of this equation and then kind of just plug it into the formula. So let's identify. The number multiplying the x squared is my a. So this is a. The number multiplying my x is b. And be careful to tell me everything that's multiplying the x, because in the formula, b is multiplying the x. It says plus b. Down here, I've got a 2 multiplying that x, but I've also got this negative 1. So you could think of this as, maybe think of it as plus negative 2 times x. And then you see, well, the plus side matches up to the formula. The b is negative 2, and that's the number multiplying my x. So b is negative 2. And then c is 1. And here's another thing to keep in mind. The formula says that there's a 0 on the right hand side. I do have a 0 on the right hand side. If I had some other number here, I would want to subtract it, put it on the left so that I had a 0. So now that I've got my a, b, and c, I'm pretty much done. I'm done. I can just write down the solution. X equals negative b. So negative b, b is negative 2. So I'll do all the simplification later. And then plus or minus the square root of b squared. Remember, be careful here. If I write negative 2 squared, that's equal to negative 1 times 2 squared. The order of operations is parentheses, which I don't have, and then exponents, and then multiplication. So the negative 1 comes after the exponent here. So this is equal to negative 1 times 4, which is negative 4. So you may be thinking, well, my number is negative 2, and that's what I'm squaring. But if you write it like this, that's not what that means. So you have to put parentheses. And in that case, you'll get negative 2 times negative 2 is 4. So that's why I put parentheses down here. And your math teacher at school might count points off if you don't put parentheses there. So do it. And then continuing on in the quadratic formula, I've got a minus 4. Oops. And then times a, so a is 3. And then times c, and c is 1. And then all of this over 2a, 2, and a is 3. And there, I've written down my formula. I've written down the solution. Now all I got to do is simplify stuff. So negative times negative 2 is 2, plus or minus, and here's a big square root. Negative 2 squared is 4, and 4 times 3 times 1 is 12, so 4 minus 12. Divided by 6, all over 6. So now I've got 2 plus or minus the square root of negative 8 over 6. Now I've got 2 plus or minus I times the square root of 8 over 6. That negative 1 inside the radical comes out as an I. And now let's see, 8 is 2 times 4, so I can write 2 plus or minus I times the square root of 2 times 4. Let me do this on the side so it takes up a little less space. Here, I'll do it over here. I know that the square root of 8 is the square root of 4 times 2. which is the square root of 4 times the square root of 2. And the square root of 4 is 2, so that's 2 times the square root of 2. So this is 2 times the square root of 2 all over 6. So this is a fraction. So I'm just going to use a little fraction manipulation here. If I've got a plus b over c, that's the same as a over c plus b over c. So over here I could write this is 2. So I'm just gonna, I guess I'm just gonna split these apart just to show you how I simplify them, and then I'm gonna put them back together. I guess I don't have to do that. I could just factor out a 2. Why don't I just do that? I'll factor out a 2. So now I've got 1 plus or minus I times radical 2 over 6. And then I can just cancel here. Cancel, cancel, get a 3. So now I've got 1 plus or minus I times radical 2. The square root is also called a radical. And that's divided by 3. This is x equals. So that is a nice looking answer. And you can plug that back in to the original equation and see if you get 0. And I bet that you will. So that's great. The quadratic formula is great. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then you just figure out what a, b, and c are, and you just plug it in, and you got your solution right there. So I'm gonna do another example. Maybe I won't carry the whole thing through. I just want to show you kind of the setup. What if I have 2x squared minus 4x plus 1 is equal to 3x squared plus 7x minus 5. Well, I've got two, it looks like I've got two quadratic polynomials here, but really, if you combine them together, it's just one. So let's just do a little math here. The formula has everything on the left-hand side equal to 0, so I'm going to put everything on the left-hand side. So I'm going to subtract 3x squared from both sides. I'm subtract. This is called combining like terms, so I'm combining all the x squareds together. I'll leave everything else alone for this step. And then I'm going to combine all the powers of, well, all the x to the power of 1 terms. So I'm trying to get everything to the left hand side, so I'm going to subtract 7x. You got to do the same thing to both sides, of course. So now I've got negative x squared minus 11x plus 1 is equal to negative 5. And finally, I would like to move everything to the left, so I've got a negative 5, so I'm going to have to add 5. Got to do the same thing on both sides, of course. Negative x squared minus 11x plus 6 equals 0. So finally, it looks like the beginning of the quadratic equation, so our quadratic formula. So I've got this number, negative 1 is multiplying my x squared. And I've got this number, negative 11 is multiplying my x. And I've got this number, which is my constant. It's multiplying x to the power 0, which is 1. And so now I've got a, b, and c, and I can just plug them in. to the quadratic formula, and I'll be done. So the last thing I want to do is, let's graph these things. So to graph them, so you start off with the knowledge that these are going to be parabolas. And parabolas, like I drew for you a long time ago, either they look like this, or they look like this. Same thing, but upside down. And you could take that parabola and shift it up or down, left or right. There's not going to be any rotations, but it could flip upside down like I drew there. And so the easiest way to draw these things is to just know that what we're drawing here is, again, ax squared plus bx plus c is equal to, well, it's not equal to 0. Let's see. This is a function. So if I call this a function of x, then it might be equal to ax squared plus bx plus c. And so what I'm graphing here is the function f. And I'm graphing it as a function of x. This is the x-axis. And so on the y-axis, I'm measuring the value of the function at x. This is the value of the function at x. And usually people would just call that number y instead of f of x. Usually called y. So usually you'll see y equals ax squared plus bx plus c. And this graph will be labeled with a y up here and an x. So you'll see either one of these. F of x is equal to ax squared plus bx plus c, or y equals that. And it's the same thing. They're either saying this is a function called f and we're plugging x into it, or they're just skipping all that and saying we're going to call the value of that function at x, we're going to call it y. So I'm just going to write y there. And then you get the xy plane like you're used to. And so there are cases where, and let me write again, if the parabola is curved upwards, then you know that a is positive. And if the parabola is curved downwards, then you know that a is negative. And you can imagine, just imagine, that we have ax squared plus bx plus c. And you're trying to think, what does this look like? Well, because it's an x squared, you know it's a parabola. And so it looks like one of the two pictures on the right that I drew. Either is curved up or down. And you just kind of we're trying to think about, is it curved up or is it curved down? Well, a way to get like your head wrapped around this is to think, what happens at the easy points? Like sometimes, like it's easy to look at a few places on your graph and figure out what happens there, and then just kind of interpolate between those places as far as what the rest of the graph does. And so I see 3 easy places on the graph to just kind of intuit what happens there. So if you look right in the middle on the y-axis, all up and down the y-axis, the value of x is 0. And 0 is an easy number to work with. If I were to plug in 0 into this function, I get a times 0 squared plus b times 0 plus c. And anything times 0 is 0, so this is just equal to c. And so that's nice. That tells me that this is the number c, the c from the quadratic formula, and this is c. And the same here. This is a positive c and a positive c. So I could actually just look from my a, b, and c, and I know where c is. So I might not know immediately if it curves up or down, but I know where it crosses the y-axis. And that's a good start. Because it intercepts the y-axis there, that's called the y-intercept. And just like with linear equations, you set x equal to 0 to get the y-intercept. I mean, the y-axis is where x is equal to 0. That's the definition of the y-axis. So that's one easy thing you can do. The other easy thing you can do is just imagine what happens when x is really, really big. Like x is a million, a billion, a trillion. X has 20 zeros after it, 100 zeros after it. It's a huge number. So if you look on this, you look at this function, the first thing we're going to do is square x. So that huge x number is going to get squared and be even bigger. Like if you have 1,000 and you square it, you get 1,000,000. So if there's 3 zeros there, now you're going to have 6. If you have 100 zeros, now you're going to have 200. So that is a huge number. And then you have x, which is big, but x squared is going to totally dominate that number. It's the biggest one. And then c is a constant. It has no effect at all. So if you have a positive a value, so what I'm trying to say is when x is really, really big, the only term in this function that really matters and determines where the curve is, the blue curve, is the first term, ax squared. So if x is a huge number, then x squared is going to be a huge number. And if a is positive, then it'll be way up here above the x-axis. And if a is negative, it'll be way down here below the x-axis. And so similarly, because x is being squared, if x were a very large negative number, say negative 1,000,000, 1,000,000 has 6 zeros, so if you square that, you get 12 zeros. But you're squaring it, so it's still going to be a positive number. And so if you look here, if x squared is a positive number and a is positive, then this first term is going to be positive. And so your curve is going to be up above the x-axis. So if I know the y-intercept, and I know if a is greater than 0 or less than 0, I can get a pretty good idea about what this parabola looks like. The other points that I need to find out about are these points here, which is where the graph crosses the x-axis. And so the definition of the x-axis is the set of all points where y is equal to 0. And so to get these points, I would have to set y equal to 0. Luckily, I know what to do when I set y equal to 0, because if you look at this y, you set that to 0, then you have a quadratic equation, and we know how to solve those because that's what we just covered. And you can solve that with, for example, factoring or using the quadratic formula. Oops. So you can solve that with factoring or by using the quadratic formula. So let's do an example. So let me write these red dots. These are x-intercepts. And you're just, you're done. If you know the x-intercepts, the y-intercept is c, and you know if a is positive or negative, then you can just draw the graph. That's the end of it. So for example, let's graph a couple of things. So I want to graph x squared plus 7x plus 2 equals 0. Okay, so what I'm thinking is maybe I want to try factoring it, but you know, I know the quadratic formula. I'm just going to write down the solution. It's so easy. So negative b plus or minus the square root of b squared minus 4ac. So a times c is 2 because a is 1, and 4 of those is 8. All over 2a. A is 1. So I have negative 7 plus or minus the square root of 41 all over 2. So I don't know what that number is, but I know that 6 squared is 36 and 7 squared is 49. So this number must be somewhere between 6 and 7. Let me just use my calculator here. So if I were just asking you to solve this equation, I would want to see that what I just wrote, negative 7 plus or minus square root of 41 all over 2, because that is an exact number. If you use your calculator like I'm about to do right here to calculate the square root of 41, there's going to be a decimal, unless it's a perfect square like 49 or 64. Or 36, it's going to be a decimal, and you're going to have to cut it off at some point, and it's going to end up being an estimate, you know. And I don't, you know, estimates are great, but I don't rather have the exact number. So the square root of 41 is, so I'm going to put a little tilde here because I'm estimating now. And I'm only estimating because I want to draw a graph. So negative 7 plus 6.4 divided by 2 is negative 0.3. And negative 7 minus 6.4 divided by 2 is negative 6.7. Okay, I've kind of misstated this problem. So the problem that I was going for was graph this equation. So I kind of not graph the equation, but graph this quadratic function. Graph this second order polynomial. You know, graph y equals this thing. And so one of the first things I would want to do is find all the intercepts. So when I find the x-intercepts, I'm setting y equal to 0. When in that case, that's when I would get x squared plus 7x plus 2 equals 0. And then I would proceed to to solve it like this. So I kind of misstated the problem there, but that's what I meant. So I would want to find the x-intercepts. I would want to find the y-intercept, which is really easy. So what's my y-intercept? Well, the y-intercept is where x is equal to 0. So to do that, I would set x equal to 0. To find the y-intercept, I set the x-intercept, I set y equal to 0. To find the y-intercept, I set x equal to 0. So when I set x equal to 0, from the original equation, I have y equals 2. And I'm done. So I got the y-intercept, I've got the x-intercepts. And then, yeah, I could probably figure it out from there. I could definitely figure it out from there. But just to, I guess, just to check myself, which way does this graph curve? Does it curve up or does it curve down? So to answer that question, you look at A, right? What is A? A is the coefficient of x squared, so 1. 1 is positive, so that means my parabola is going to be opening up. So let me just put all these things on this graph. This is x, this is y. This is just a sketch. So I'm looking here, I'm going to need to plot a point all the way down at negative 6.7. So just make that a little wider. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. And 1, 2, 3. 1, 2, 3. So the y-intercept is y equals 2. Okay, so here's y equals 2. So that's on there. Let's see, I've got an x-intercept at negative 0.3, so I'm just going to say that's about here. This is negative 1, so half of that's negative 0.5, so negative 0.3 would be maybe right there. And my other x-intercept is negative 6.7, so that's maybe right there. Okay, so you can kind of see how this parabola is going to look. It's going to curve, it's going to hit these 2 points and continue up this way. So I'll try to sketch that. Kind of missed there. But it looks something like that. It's curved up, A is positive, it hits my 2 x-intercepts, and it hits my y-intercepts. So one thing you can do when you learn calculus is you can learn how to find this minimum value here. Find the 2 points. The x value here and the y value. And then there's applications. That's called minimizing the value of that function, and that's the minimum point right there. And in calculus, you learn how to find that that point. So that's all you really need to do. You have the equation, you have the quadratic function that you're given. You set y equal to 0, which turns it into a quadratic equation, which you can solve now to get, if you set y equal to 0, you're getting the x-intercepts. And then if you set x equal to 0, you're getting the y-intercepts, and that's always c in the quadratic formula. And once you have those 3 points, you should be able to just draw the graph. So today we talked about quadratic equations, how to solve them, a couple of different ways to solve them. You can do it by algebra if you don't have a linear term, x to the power 1. And then you gotta just take it slow at the point where you have an x squared, and you take the square root of both sides, and the square root of x squared is the absolute value. And then in the next step, you remove the absolute values and put the plus minus on the other side. Just take that part slow and easy. If you do have a linear term, then just write it so that it looks like ax squared plus bx plus c equals 0. And then just use the quadratic formula, which is very nice. You can just write down the solution. And then graphing, to graph these things, you just need the x-intercepts and the y-intercept, and then you can just kind of sketch the curve there. So you might, so when you graph these parabolas, like this blue one I graphed just recently, it might be the case where that parabola is shifted up so high that there are no x-intercepts. And so that's kind of a special case that I'll get into in another video. But if that parabola were shifted up so that the very bottom minimum point of that curve just touches the x-axis, that's the case where you get two solutions, but it's the same number repeated twice. So you have a multiplicity of 2 for that solution. And then if you raise it up even more so that that parabola does not even touch the x-axis at all. So this is the first thing I was talking about, if it only touches once. So these are special cases. This is if you have one x-intercept. So when you look for x-intercepts, you'll find one solution, but it is said to have a multiplicity of 2. Or you could have the scenario where your parabola has no x-intercepts. So how you're going to know that this happens because you try to solve for the x-intercepts, but you get x is an imaginary number. So this is the x-axis here. All of the real numbers from 0 to infinity on the right and down to negative infinity on the left. All those real numbers are on this number line, but there are no imaginary numbers on this number line. So if you were to solve for x-intercepts and your x's are plus and minus I times whatever, those are imaginary numbers. They're not going to show up on this real number line, and that's why your blue curve won't touch them. So these are special cases that I'll talk about in another video. But if you have any questions on any of this material, then please leave it in the comments below, and I'll respond to all of your questions. Thanks. Thanks for watching. If you thought it was helpful, click the like button. Be sure to subscribe to get more videos like this in the future. And if you have any questions on what we covered today, leave them in the comments below. For Dr. Smith's math class, this is Dr. Smith. Class dismissed.